Okay. I am V. John Reddy, working as an assistant professor in the Department of Physics from Nalla Narasimha Reddy Engineering College. Today we are going to discuss about a small topic regarding Ruby laser. Today we are going to discuss about Ruby laser construction, working and principle of the Ruby laser. A Ruby laser is a first laser which is constructed in the year of 1960 by T.H. Myman, and it belongs to solid state laser. Ruby laser is a solid state laser and it is a pulsed laser. It is having 3-level pumping scheme. The next, coming to active medium of this Ruby laser. Active medium is, in this one is ruby rod doped with the chromium ions in the order of 0.05%. Ruby rod is doped with the chromium ions with the order of 0.05%. Due to the doping of the chromium ions, it appears as a pink color. Al2O3, ruby rod Al2O3 is doped with the chromium ions, Cr+3 ions. This is active medium, and the active centers is the chromium ions. Active medium is ruby rod doped with the chromium ions, and active centers is chromium ions. Energy source and type of energy source. Here the energy source is we are taken xenon flash lamp. Energy source is a xenon flash lamp for the pumping scheme, and type of pumping is optical pumping. Here we are using optical pumping method for the excitation process for absorption process. And next, construction. Here we are taking the ruby rod in the range of the length of the rod is 2 to 20 centimeters and the diameter of the rod is 0.2 to 2 centimeters, and the two ends of the ruby rod is well polished, and painted with the silver, and one is those two ends, one is acts as a mirror. One is fully reflecting mirror and second one is partially reflecting mirror, and this partially reflecting mirror is transmits the light 10 to 25%. The ruby crystal is placed, along the axis of xenon flash lamp, and this ruby rod is protected from the heat by enclosing in a hollow tube through which cold water is circulated, and this ruby rod is around the ruby rod, and this is complete setup is placed in a hollow tube. On the top we are circulating the cold water. This cold water is absorb the excess heat and maintain the constant temperature. And the ends of the flash lamp are connected to a high pulsed voltage source so that the lamp gives flashes of an intensive light. The flash lamp is connected to high voltage source and it gives the high intensive pulses. These pulses is absorbed by the ruby rod, and inside the ruby rod the chromium ions are excited, and the excess energy is absorbed by the cold water which is we are circulating around the ruby rod. Okay, next coming to working. The chromium ions are working. The chromium ions are responsible for the stimulated emission of radiation, whereas aluminum and oxygen ions are passive, sustaining the lasing action. The chromium ions absorb the radiation of wavelength around 5500 angstroms green color and 4000 angstroms blue emitted by the flash lamp and get excited to higher energy levels, that is F2 and F1 energy levels respectively. from the ground state. Here we are seeing the diagram is there. The atoms is observed the two different kinds of wavelengths. If it is observed the green wavelength, that is excited to F2 energy level, it is observed the blue light, that is excited to F1 for F1 energy level. And this F2 and F1 is the higher energy states, and these are stay only very less time, that is 10 to the power of minus 8 seconds. After that, the atoms comes to its lower energy level, that is E2. That is energy level is metastable energy level. In these two atoms comes to E2 level are rapidly non-radiative transitions. That is not emitted any light. Rapidly they are come to its lower energy level from F1 and F2. Here we are achieve the population inversion in between E2 and ground state atom. Ground state, E2 metastable and ground state, there is a population inversion occurs between this metastable level and ground state. After once we achieve the population inversion, the atom says the lasing action is started. Due to the lasing action, we are getting the output is in the order of 6943 angstroms. Next, the population inversion takes place between the metastable state and ground state. As a result, stimulated emission takes place, giving rise to the emission of light of wavelength 6943 angstroms. This is a working of the ruby laser, and here the ruby laser output is emitted in the form of a pulses. It is not a continuous output. The major disadvantage of this ruby laser is, even though it is a high intensive, but it emitted in the form of a pulses. It waits for 2 to 3 milliseconds, one pulse to another pulse. First it emits the one pulse and it will stop. Wait for some time, then it emits the other pulse. This is a drawback of the ruby laser. Okay. In the next